give it 2 more minutes. All right, well, we're going to go ahead and get started. Everyone, of course, is welcome to continue meeting. This is technically a lunch meeting, so eating is normal. This next set of slides, and it's really the stuff that we're going to be talking about now through this area, basically until Dave's part comes up, which is going to be talking 30 minutes or so. Is really how we grow things at Google from a reliability perspective, how we think about reliability, how we think about application reliability, how it comes together. And then also, as I was putting this together, I've actually helped with some of the Palo Alto outages and troubleshooting things in the past. These are just some of the ideas I have is like how things could be, other features and stuff like that may be useful for things like reliability and scalability and things like that. So not really just a few things in there. Okay. All right, so from the way that we look at the network, really in a lot of different ways, right? Is the way I like to look at it. Is the network and get to wherever you're going, right? Whether that happens to be, this is a picture actually of data centers from several years ago, but it's a giant warehouse essentially full of computers. And of course, networking stuff that sits on top of all the fiber and stuff, so that's in between these things. And then, of course, these things have to communicate. The picture on the right-hand side is a microwave tower. I don't recommend microwave towers unless you have a backup, or unless you really care about latency. They're really good for latency, but higher than latency essentially air. So, but yeah, networks have to be able to transmit stuff between sites, right? And inside the Google network, we have to look at it a number of different ways. It's scaling. If you start off in a small business type scenario, right? You're building these things out. Well, you're going to maybe build out a couple, your data center with a few racks. You've got a couple of different routers. You're like, this router is here, and this router is here. Maybe I'll have redundancy because I have two of these things. But I want to name this router, one thing, and name this router one thing, and they're going to be special, right? But that doesn't really scale, right? As you start adding more and more and more things, right? The scalability that you have can't be, well, every router that we have is the same, right? We can't necessarily look at this as a, as individual chassis of routers, right? This has to be a group of routers in a particular way. That has to be a fabric, right? Or a block, or whatever you want to call it, right? And these things can't be customized individually, right? Again, maybe you're starting off small. It's an easy way of doing it, right? Is well, this one needs this particular setup, and this one needs this particular setup, and this one needs this particular setup. But then you end up with hundreds of these things, and you're like, what was that setup that I used that one time? And you start losing track of these things, and outages start to happen. And that's always a bad thing. There's never one outage, because outages are always bad, no matter what. But the common phrase that can be used to clarify that, right, is these things have to be treated ultimately as cattle, right, not as individual pets, right? You have to be able to look at these things. And then fault tolerance and software, right? The hardware itself is going to fail. You know that. And so understanding how that failure is going to happen is obviously important. And strength in numbers really meaning, okay, we have to be able to fail everything, the different software. The software is also going to fail. You're going to have software bugs, right? We have to be able to roll out new software features in a way that is going to support this, right? But then it has to be able to work with these different systems here. And from the networking perspective, right? If you look at the networking perspective, you can say, well, we need to be able to have we can solve this. We can just have a super reliable switch or a super reliable pluggable optic. Well, the math on this just doesn't work out. So let me explain, because I actually wrote down the numbers, but they're not in front of me, so go on. So if you have a switch, right, and maybe you get a super reliable, it's a 20-year mean time between failures, right, which if for a switch is actually really good. So if you have a switch, it's like been up for 20 years, let me know if you want to be very impressed at that. But if you have a fabric that has 1,000 of these, right, now only 1,000, like I'm not talking about like a Jupiter that probably has way more than that, but you have all these 20-year switches, you still have one switch that fails per week, right, on average, right, and this is in TPF and how that math works out. So you still have to be able to survive these things. You have optics, right? We have amazingly reliable optics. We can say, okay, MTBF, I just pulled in some numbers, say 50 years, right? This optic will not fail for 50 years, which is, think of all the technical advantages or technology advantages that happen over 50 years, but these optics are amazing. You have maybe 20 of these in these reliable switches. One of these isn't going to fail per day. Right, even with the 50 optics, right, you cannot rely on a network that is using super reliable hardware. You are going to have failures, right? We had a slide earlier that showed all the different transoceanic and some of the internal links that are connecting the networks together. That's just simply like the long haul stuff. If you look at the stuff inside the data center or the stuff inside the region, it is huge amounts of hardware, huge amounts of switches, huge amounts of all these different things. And so really from the Google perspective, we know that these failures are happening. And probably as I've been talking, we've had probably easily a half dozen failures just in the last few minutes, right, of stuff that happens, right? These failures are constant. And you have to have the network understand that these things come together. So just simply, just expecting the hardware to recover isn't the thing. You have to have systems, you have to have the software and stuff like that understands this and ultimately makes the system reliable, right? This is more just where we come from. Basically, there's a lot of different things that tie into this. I'm not going to worry about that slide, actually. Again, software is where this comes from. And when we say software defined, that means a number of different things, because SDN software defined stuff is but generally speaking, but it has to be in a way that itself is scalable and itself grows, because you don't want to have all these individual things that are basically all trying to do the same thing.